Test, test. Okay, so hello everyone, and welcome to the OneClass channel. My name is Donna Riel, and I'm a recent master's graduate in the Materials Science program at the University of Ontario Institute of Technology, also known as Ontario Tech University. I also took my Bachelor's of Science in Pharmaceutical Chemistry at this institution as well. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or tutoring, then just visit the links in the description below. Okay, so I'm going to get started with the first set of questions. Okay, so the first question states, in each reaction box, place the best reagent and conditions from the list below. So just analyzing the reaction so far, we have just two carbons with a triple bond, and then they form this structure that has more carbons than what it started with, and also two bromine groups. So I'm just going to write this down. Question 1. Okay, so we need to use a reagent that will be able to attach new carbons onto this triple bond. And we also want to end up reducing this triple bond in the end, since they're all single bonds in the final product. So first, I'm going to be using sodium amide. I'll just explain why in a bit. Okay, so when you react this sodium amide with the triple bond, you get this acetylide ion. So this is actually an excellent nucleophile. And what it does is that it's able to react with alkyl halides to form new carbon bonds. Okay, so that's step 1. Just gonna label these as A and B. So that was A. So then after we have this acetylide ion. And then from there, in our final product, we add 2 new carbons. So therefore we can use just this ethyl group with the bromine there. And then we're left with this structure. Okay, so we have successfully added our new carbons, and now we want to somehow add in our bromine groups. So to do that, we also want to reduce our triple bond as well. So we can actually add 2 equivalents of HBr. So the first equivalent will reduce the triple bond to a double bond and also add a bromine onto one of the carbons. And then the second equivalent of HBr will reduce that double bond into a single bond. And that's how you would attach your 2 bromines. Okay, so and then we're left with our final product. So this is a 2-part question. So I'm just going to start this on a new page. So this is still question 1. Continued. Give the correct organic products in any order for the following ozonolysis reaction. Okay, so we have this hexane, and at the top we have this double bond. And then with these conditions, this is known as an ozonolysis reaction. Okay, so let me write down what the ozonolysis reaction is. Basically, this reaction produces carbonyl compounds. So by carbonyl compounds, I mean either ketones or aldehydes. And then first, your O3 forms an intermediate with the double bond alkene. And then next, the zinc reduces it. Okay, so it's actually pretty easy to figure out what the products are from this reaction. Wherever you see the double bond, I kind of just like to draw like a line that breaks it into 2 different species. And then wherever the line broke, you just replace it with either a ketone or an aldehyde. So the first product will look like this. And then the second product will just be this ketone. Okay, so you can see, I'll draw an H here. Wherever I drew the line to break the double bond is where the new aldehyde or ketone would form. Okay, so let me just confirm with the answers here. So from question 1A, we would use the sodium amide, and then the ethyl bromine. I think they might have used an extra carbon there. Yeah, so the second one should just read CH3CH2Br, but then the HBr2 equivalence is correct. And it doesn't look like they answered question number 2, so I'm just gonna write it in. Okay, so I just said the sodium amide and 2 equivalents HBr correct. You should use CH3CH2Br in the second step. For the second part of the question, the starting product will separate at the double bond, forming 2 new products containing carbonyl groups in its place.